G'day flatties and globe defenders, it's Critical Think from Down Under, and we're going to continue with part 2 of the sunrise analysis, and we're going to include the sunset in this as well. And look, I'm sorry flatties, it's more bad news, but I guess you're just getting used to that now. This is what I'm aiming to achieve in this video. By correctly analysing real-world observations using scientific methods. In this video I will show that the observations of sunrise and sunset are entirely consistent with globe model predictions. I will also show that these real-world observations are inconsistent with flat Earth model predictions. Number 1, the sunrise and sunset crosses the horizon. 2, the horizon does not rise to eye level. 3, the azimuth of the sunrise and sunset. 4, the direction of the sun as it travels through the sky. 5, the sun's angular size remains consistent. And 6, the sunlight reflected off the bottom of the clouds. So let's get started. We'll do a quick recap of part 1 where we looked at a sunrise over the ocean on the 2nd of September. And we've got the sun emerging over the horizon. This is completely contrary to the flat Earth model, even though the flatties will not accept that. On the flat Earth model there's two problems. The sun should be above the horizon, and it should come from a smaller size to a bigger size. And it should move from right to left. But none of those things happen. The sun emerges from below the horizon. It remains circular in shape and the same size while it's emerging. It remains the same size. It goes up over the horizon, and in the southern hemisphere it moves in the other direction, which is to the left. So that makes the flat Earth impossible. So now we're going to discuss a little bit more detail of why this can never happen on a flat Earth. We're going to start with the azimuth or direction of the sunrise. Now this picture is from my second challenge video where I invited flatties to make the calculation and prove that the Earth is flat by looking at the direction of the sun. So as pretty much expected, none of the flatties have done any such calculation. In fact, they just totally ignore the direction of the sun. But anyway, so we're going to do the calculation here. Now, according to the globe model, which is programmed into timeanddate.com, on the 1st of September, sunrise at 6:02 AM at about 81 degrees. Now, that building there is a very distinctive building in Brisbane, 1 William Street. So I've drawn at 1 William Street. Now, this picture has a hole in the ground there because the building wasn't built yet, but it's there, William Street, 1 William Street, and the observation at Mount Coot-tha. And this way across here is due east, which is 90 degrees, and this is very, very close to 81 degrees. So that pretty much confirms that the globe model is verified by that observation. The globe model predicted that observation, and it was observed in reality. Now, there's another observation I can make from this picture. So we've got at 1 William Street, I've got, it says there the elevation is 19 meters. Now I don't know where the ground floor of that building exactly is, but let's make it 19. And the height of this building, now we're looking at the height here, I'm going to try and work out. So it's about 180 meters to here. and 260 meters to the top of that spire, so this makes it about 220, and we add 19, makes that about 240 meters high. Now it's not exact, but it's going to be close. And then let's just look at what we would observe on the flat Earth using Walter Bisland's calculator as compared to what we might see on a globe Earth. Now the observer height at Mount Coot-tha, I've taken 236 meters from the metadata on the photograph, and it's 6,670 meters from that measurement I just showed earlier, and the zoom factor, okay, I don't think that matters much here, but the important thing here we've got is that it should be, I think it should be that the horizon is either at the top of the building, because our eye level is very close to the top, or the horizon should be about 3/4 of the way up this building. And we'll see which model matches the best. So when I looked at this first, it was very difficult to see where the horizon is because of the haze and the dust in the sky. But one thing we can tell from this is that the flat Earth predicted horizon, which should be there, is just not present. You can see the sun below the top of the building there. So the flat Earth model fails in this regard. This observation is inconsistent with the flat Earth model. Now, you cannot see exactly where the horizon is there, so I've gone back to some of my earlier photos. And again, the haze doesn't make it super clear, but this is a pretty good guess for the horizon there. It's within very close to that line. These mountains on the island out there are above the sea level horizon, so that's not the sea level horizon, but you can see that that's a horizon there. And again, similar photo. So to the left there you can see the land mass gets smaller and smaller, so that's why I've drawn that line there. And the horizon again in a similar place. You can see over to the left here where the sea level is. There's no islands poking up, so you can see where the sea level is, although it's still not super clear. But it's obvious that the horizon is not at the top of that building. And there's a part of a video I've taken yesterday actually, and again you can see that the horizon is definitely not at the top of the building, and more like down there on that building in question. So I've drawn a line here which is my best estimate based on all those photos of the horizon. I have to wait for a clearer day to get the exact position, but we definitely know it's not up here. You can see the sun below the building. In the other photos you can see the sky behind the building down to about that level. Now this is still a little bit higher than what I first guessed, so I'm suggesting that perhaps 240 was a little bit too high. Now I was just trying to work out the height of that building. I didn't know exactly how high the ground floor was above sea level, so I took it as 19 meters. Maybe it's 10 meters. So you can see that this is my earlier prediction, and if the height of the building was 230, then that brings the horizon level on the globe prediction are much closer to what I can see in the photos. The thing is, it's very close to the observation, and the flat Earth model prediction is inconsistent with the observation. So that's the important thing, and we'll get a more accurate picture of the horizon when conditions are clearer. But this much is clear right now, that the horizon is not at eye level. It is definitely below, and a good deal below. According to the date, I should have put the 1st in there because I think that observation was on the 1st, so it's not much different. So according to the date, the 1st of September, and in Brisbane, it's not much different. That was so it's pretty much in the same place. 6 a.m. Brisbane, the sun's going to be somewhere in that vicinity. So we also have a look at the flat Earth map, and the most accepted map is the AE map, although it doesn't really matter for this because from our observation point the sun's going around in a circle. It's nearly at the equator on September the 1st. The sun's going around in a circle. At 6 a.m. it's going to be approximately 90 degrees away, and that's very similar position as displayed on the timeanddate.com. Now here's the thing from Brisbane. The due east is in that direction, which is a tangent to that line there, so that's in that direction. 81 degrees is in that direction, and on the flat Earth with the sun going around in a circle, the sun would be seen in this direction, which is a long way away from 80 degrees. So the 80 degrees observation was confirmed from the globe model, and the flat Earth observation is not confirmed. It's the sun position on a flat Earth is inconsistent with what we observe in the real world. So there's another from this map also. I'm just, before we go on to the distance to the sun, it's a funny thing, even Rob Skiba has acknowledged that this map is a projection from a globe, and I have no idea why he still insists that the Earth is flat when the map works for a globe. But anyway, here's why, another reason why flat Earth is impossible. The distance to the equator is 10,000 meters or 5,400 nautical miles. So the circumference of that circle, which would be around the equator there on a flat Earth, is 62,000 kilometers thereabouts. And what is the circumference of the sphere? It's actually 40,000 kilometers. If you were to go around the equator, that's how far you would travel, and that's the distance that it really is. So the distance to the pole, 10,000. It must be over a curved surface because it's not 62,000 kilometers around there. So there's another fail for the flat Earth. Now we go on to the distance to the sun, which we can calculate from this flat. I'm talking about distance to the sun on a flat Earth, just to clarify that. So we've got the distance to the equator is 5,400 nautical miles. The sun's position is approximately 5,200 nautical miles. And on these equidistant maps, these distances are correct. From the pole to the position, they're all correct. So from the North Pole to Brisbane, it's approximately 7,830 nautical miles. And we want to find the length of this green, which is the horizontal distance to the sun. So we plug that into a triangle calculator. 7,830 along one side of this triangle. It's a right angle triangle because that distance, that triangle there is approximately, is very, very close to a right angle for 6 a.m. in the morning. And we plug that in and we get that it's 9,400 nautical miles. So we know that the sun, well, the accepted sun height is somewhere between 3,000 and 5,000 miles. We'll take the lowest value because that gives the best flat earth answer. 3,000 miles, which is 2,600 nautical miles. It's 9,400 nautical miles on horizontal distance. So that makes the angle to the sun 15 degrees. So at 6 a.m. in the morning on a flat earth, the angle of the sun should be 15 degrees. Now, the sun rising at sea level is a long way from 15 degrees. So this is what 15 degrees looks like. It's very, very high in the sky. And we will delve into the so-called atmospheric lensing solution to that, and I'll talk about why that's impossible. At 15 degrees is a long way, and we're expected to believe the flatties claim that there's some kind of magic going on here with refraction or even perspective that would make up for a 15 degrees discrepancy. You know what? I don't think so. That's I just got to laugh about that one. So just to compare this with, you remember like D. Marvel's laser over water, 10 miles over the water, 30 feet. Now, the amount of refraction that would be making up for this 52,800 feet for 30 feet, little bit of refraction, the angle, the total angle of refraction there is 0.03 degrees, which is a very, very tiny angle, and all the flatties all complain about, oh yeah, you always claim refraction. Okay, but that tiny little bit, you compare it with what you're trying to claim, flatties, 15 degrees. Look how much 15 degrees is. And like I've drawn the line here at 1 degree, and 0.032 degrees is 30 times smaller than this. So for a laser to curve over a lake, it requires 0.032 degrees. And the flatties complain like crazy about that. But at the same time, they accept that they can make up a deficit of 15 degrees. I think I'll have to laugh about that one. This day that I took these photos was a severe dust storm, a rare event. So you would assume that there's no water vapor in the air. And we'll go on to see why that's significant. Rob Skiba, the man himself, says that on days when water vapor is not present, the sun shrinks. So we'll look at that shortly. Now, Rob Skiba came up with this scheme for atmospheric refraction, claiming that moisture in the air would cause a magnification. And he's got this little demonstration which I'll play now of how he thinks the sun could set under these conditions. So I'm just going to play that. And so I did try to reproduce that, and I'll show you my results. So I tried to reproduce this, and any scientific principle should be reproducible, and I found it very difficult to get conditions exactly right with all the angles and heights, and so I couldn't reproduce what he produced, but I came very close. And when I moved my sun away, it actually looked like it was coming closer. So I don't know what else I did wrong, but suffice to say, it was very difficult to reproduce. So you got to think about atmospheric conditions, how unreliable they are in producing something exactly. How could the atmospheric conditions magnify the sun to the exact same size as it was at noon? That's absolutely ridiculous and absurd. And for them to be exactly right to make this appear like that is absurd as well. And there's no distortion. There would be distortion, incredible distortion for atmospheric effects. We already see that in the refraction pictures and photos. And just by getting it wrong, I'll just show you a little video now of just changing a couple of variables, how it can look different. So just by changing the positions of some of the things, you can see that the effect is not reproducible, not very easily. I mean, I just changed some of the positions of the lenses and stuff and camera, and when you move away, it actually looks like that picture of the sun is getting closer. And so, you know, you could get all kinds of effects if atmospheric lensing was a thing, but it's totally absurd. It's a totally absurd concept, and it doesn't fit with observed reality. Now, Rob Skiba also goes on to say, and of course, when there is less moisture in the air, it will look like this as the sun travels on its circuit. And so, no moisture in the air, the sun should shrink. Okay, we'll take a look at that. This is the photograph I mentioned before, taken during a dust storm. So there'll be no moisture in the air. So according to Rob Skiba, the sun should be shrunken. So I'm going to measure the angular size of that sun. But before I do that, I'm going to look at some recent observations at sunrise and sunset. Now, Wolfie did one in Broome, where he verified that the angular size of the sun matched exactly with the expected duration that the sun would take to set. I did another observation on the east coast of Australia and did measurements on, you can go to these videos, I'll put the links in the description, and did measurements on the sunrise and again confirmed 32 arc minutes in angular size. And then I also did a sunset observation and analysis in Thailand, and again 32 arc minutes confirmed. Globe observation confirmed, very consistent with globe model. The angular size of the sun is consistent. This is the photo I'm going to use to calculate the angular size of the sun. Now you can see from the metadata that it was taken on Saturday, September the 1st, 2018 at 6:05 AM. The pixels across, this is the important one, is 4,608. There's also the zoom level here, 321 millimeters. The camera is a Coolpix P900. I've opened up this picture in paint. On this edge of the sun it's at 1230 pixels, and this side of the sun it's 3440 pixels. So here's a calculation of the angular size of the sun from the observed reality. From the photo we get 321 millimeters zoom. The pixel width of the photo is 4608 pixels, and the pixel width of the sun is 2220. Now the P900 sensor width is 6.17 millimeters. So we can calculate the field of view by using this equation: 2 times arctan, 0.5 times the sensor width over the zoom. And that comes out to 1.10126 degrees for the field of view in that photo. And so the angular size of the sun from this is that amount of degrees multiplied by the pixel width of the sun and divided by the pixel width of the photo. And that ends up with 0.53 degrees, or 31.8 arc minutes, which is damn close to 32. So we've confirmed that on a dry day when there's no moisture in the air, the sun is still 32 arc minutes, which is a globe model prediction. Now we'll calculate the angular size for the flat Earth sun. At midday the sun is directly above and closest, and the angular size at midday we're going to take as 32 arc minutes. Now the height of the sun we assumed before was 2600 nautical miles, and the width of the sun using this formula works out to be 24 nautical miles, and which is about 30 miles. At 6 AM, now the distance to the sun from my earlier calculation was 9,400 across and 2600 nautical miles above. So that gives a distance along the hypotenuse of 9,752 nautical miles. And the angular size of the sun at 6 AM therefore should be 2 times the arctan of the diameter of the sun over 2 times the distance. And that works out to be 8.46 arc minutes it should be, which is about the quarter of the size that we observed. So the flat model prediction is deemed inconsistent with reality. So I'm going to finish up with some photographs from sunset and sunrise where the sun is reflected off the bottom of clouds, which of course is impossible for a flat Earth. Now I'm not going to do the geometry. I know this is probably going to confuse a lot of flatties, and but I should do a geometry diagram, but I think I've run out of time on this video. So just enjoy the photos and the impossibility of flat Earth. Now these photos here are from the user travel videos. I'll put a link in the description. Some very nice photos there. And all bad news for flat Earth. So thanks for watching, and please subscribe if you like my videos, and we'll see you another time.